Hello, guys. Welcome to today's episode of Smart Dev Saturday. Can you believe it's episode 004 already? And I hope you've been having fun on this ride with me. Yeah, I know last week was really long, about 1 hour 25 minutes. So I'm trying to keep this as little as about 30 minutes. So God help me. Yep. So last week we talked about what did we talk about? Yeah, core programming concepts. But this week we're going to be showing a little more code. Of course, not very much in depth. So to not waste much time, let us get started. So last week we talked about the core programming concepts. We talked about storage and processing. Our computer stores data. We talked about data structures, where we talked about some things like stacks, queues, and all that. So if you didn't get last week's episode, you can go watch it on YouTube. I uploaded it last week because there was some internet glitches last week. And we also talked about algorithm decision making, where we talked about if else conditions. Now we talked about repetitions, the kind of loops we're using processing. So to not waste much time, let us go into today's episode full depth. So this week we'll be talking about object-oriented programming. Yep, interesting, right? So let us get really down to it. So, yep. So, talking about object oriented programming, I need to quickly change something here. Just give me a few seconds. I need to move this cam to this side. Yep, that is done, and then I can go back. Yeah, I'm back to where I'm supposed to be in that inset. Yeah, things like this happen. I had to change the video resolution. But yeah, I'm back. So this week we're talking about object-oriented programming, and yeah, this is the four things we'll be talking about. Of course, the concept in object-oriented programming is more to this, but I'll be touching on this for today. In some other series, in some other sessions, I'll be going much in depth into other parts. Of course, as we write some code, I'll be making some pinpoints about them. Yeah, so let's get started with classes. The class, so when you say write this class that does this and that and that and that. So in programming, when you talk about a class, it is a blueprint or a structure for an object. We said an object in object-oriented programming, we try to model real life in computing terms. So, for example, I have yeah, I got this phone here. So this phone is an iPhone 7. So what are the attributes of this phone? It has attributes. It has a battery. It has a camera. It has the fingerprint sensor. It has the power button, and it can do stuff. So if I were to model this in programming, there are lots of iPhone 7s in the world. Yep. So to make this iPhone 7, there is a blueprint, the structure of how it's supposed to look like, the number of diodes it's supposed to contain, and the things it can do, right? So that is the class. So the class is used to structure an object, in this case, the phone. So you take a shirt, a car, or any kind of thing. So in this demo, we're talking using cars because I'm thinking about cars a lot these days. Yeah, so it has attributes. So those are the features. So if you say, oh, I have an iPhone 7, 128 gig, this RAM, this A something bionic processor, whatever Apple calls it, and then and it has behavior. It can make calls, it can send messages, it can connect to the internet, it can do stuff. Yep. Just like we are human beings, we can do stuff and we have attributes. I have my color, I have my features, I have things I like, and I can do stuff. I can talk, I can walk, I can move around. So those are attributes and behaviors. And then, of course, the class is always reusable. It's just like an architect. Say you design the structure of a house, you are able to use that design over and over again depending on the kind of customers you have. So that is simply what a class. It's a blueprint. It's an architecture. Permit me use that word in the sense. So what we have over here is I'm just trying to model an automobile. Of course, I'm not an expert in this field, so I just put up a few things in my head. So a car, so an automobile in this case, that attributes like the make, the model, the year, the kind of engine, the kind of transmission, the automatic or manual, and the things it can do. It can start, accelerate, reverse, and stop. So that's that. So let me just go ahead and clean all that. So, oh, not to jump ahead, let me just show you what a class looks like in code. So I'll open to Visual Studio. I said we'll be writing C sharp for this, but of course, this concept apply in any programming language you decide to use. So I modeled an automobile here. Now this looks a little bit complex, doesn't it? Even I'm trying to understand. But yeah, just to explain, I have the private fields here. So these are the attributes. It means I'm not able to modify them or tamper with them, but I can access them through this public getters and setters. Don't let me say more than that because of course we are not using C sharp in this model. So you can set these properties through here, and of course you can access them by calling this. So you have all this, and these are the attributes. All right. So let me just make comments on that. So let me say these are okay. These are attributes. Permit my spelling, please. These are attributes, and these are behaviors. Or some programming languages here you call it methods. Some call it functions. All right. So in some languages this is called fields. Okay. Or properties. Okay. Right. So that is it. And of course, if I want to now make an automobile, because I have these properties and attribute sets and behaviors, I have all of this. Uh, so what I can now do is to make an instance of that object, of that class, of that structure. So if I go to my program now, I am just saying I'm creating a new automobile and I give it a name, my automobile. You can give it any name you like, of course. Now it becomes automobile as a class now becomes a variable. Now this automobile is now the name of this variable, and then it's a new instance of the automobile. So I'm getting that structure from the blueprint document and using them. So I am not actually modifying automobile in itself, but I am modifying the instance of it. I am not affecting the structure at all, but I'm getting a copy of it and working alongside it. So I make a copy of the automobile structure and I give it the attributes I like. I say the make is a Toyota, it's a Prius, made in 2015, it's an hybrid engine, and then it's automatic. You realize I can make this manual if I wish. Now, what just happened is called intelligence. It happens in Visual Studio and VS Code if you enable such stuff. But of course, some IDs also have the Visual Studio is just that awesome. Okay, so and I'm telling this to output to the console that we have our Toyota Prius 2015. Okay, so that's what it's gonna print out. So if I decide to go ahead and run this, so let me run this now and let's see what happens. So when I run this, it goes ahead to compile, and then you can see here, let me, okay, good thing I can actually zoom in the console. This is cool, yeah? Yep. So you can see we have our Toyota Prius 2015. You can see that. So that's just because we have declared that we have a Toyota. Yep. A Prius 2015. So if I were to go ahead and change this, let's say okay, it's gonna stop because we call this a Corolla, right? And then we run it again. The output of the console will now be a Toyota Corolla 2015 hybrid. I'm not sure if that exists, so pardon me. So yep, it's coming up now in a bit. So you can see a Toyota Corolla 2015, just like that. Yeah, sorry, I'm not advertising for Corolla here. It's just the name that came to my head. All right. So that is that about classes. So now let us go ahead and talk about encapsulation. Now, encapsulation simply is embedding the data, that is the attribute and the behavior, in a single class. And this can be hidden from the user. You can decide to hide it or not, of course. And I'll show this in code much later. And then the behavior is usually exposed through interfaces. And then the data members cannot be changed directly, but you change them from the instances. Okay, so before we go into inheritance, let me just show us what that looks like in code. So if I open up encapsulation here, no, not this. Yo, okay, this is it. So what I'm talking about when I say, just a moment, I lost the wire here. Uh, yep, let me just power it on again. All right. So if I now, so this places, I'm not able to edit it. I'm not able to change it, but I am able to access them through these public interfaces. And then these behaviors are sort of like the interfaces are used. So I think maybe next week I'll touch on interfaces and how those things work because I've not been able to touch it in this episode. Of course, if you don't like to hear about it, just let me know. All right. So that's just simply encapsulation. I declare the behaviors and the methods and the attributes and the behaviors and the data in the same class. Everything goes all in one place. So that is simply encapsulation, and I'm hiding some properties and attributes from the user, and I only access them through the instance of that object. So if I were to actually run this, so in the encapsulation one, I made some few changes. So let's just run that and see how that goes. So what I did is I made it do a start, accelerate, reverse, and stop, and I'll see what actually happens when that runs. So let me put this in full screen and do some zooming. So it's coming up. So you can see we have a total price 2015. Yep. The car engine is starting because I called the start behavior. Because I call the accelerate behavior, it's accelerating. Because I call the reverse behavior, it's reversing. Because I call the stop behavior, it is stopping. So that's simply it. Yep. And then when we go to inheritance, now in some cases, offsprings look like their parents. Yep. That is simply inheritance. So a class can inherit attributes and behaviors of another class in itself. That's simply what inheritance is. Taking the properties, or so it now introduces the concept of a superclass and a subclass, or a derived class or a base class rather. So, for example, a a a car is a type of automobile. Yep. A truck is also a type of automobile. A power bike is a kind of automobile. You get the concept now. They are so they have some things that are some functionality and properties that are similar to all automobiles that they just must have. They must have an engine, they must have some steering wheel, sort of, even if it's driven by a robot. So all these things are peculiar to automobiles, and it goes across if it's a car or a bike or a truck or a SUV, whatever. It's an automobile. So these properties and behaviors can now be grouped into the superclass, and then other classes cannot derive from it. For example, an animal will have the name, the species, and all that. And then a dog is a kind of animal. So a dog can bark, but a dog can also make a sound. because it's an animal. Meanwhile, also a chicken can make a sound, a dog can make a sound. So that sound behavior can be put inside the animal properties. Right. So that is what I needed to explain there. So it's just like a parent-child character trace. So it also allows for code reusability. So if you go use this concept of inheritance, you're able to reuse code multiple number of times. So to not waste much time, let me go and show that demo. So inheritance is as simple as this. So in the inheritance program that I have here, what I've done is I've created the automobile class. Yep. But now I have created the car class. So let me actually comment this out for now. Yep, or not. So what happens is in C sharp, this is how we do inheritance. In VB, F sharp, Java, the ways might be different. Of course, I know it's different in Java, of course. I think it uses extend something. So it says the car inherits from automobiles. Anytime I call the car instance, I'm also calling an instance of the automobile because it has gotten the behaviors and properties from it. And of course, it can have its own properties and classes, its own properties and behaviors rather. So if I now go to my program, you can see it here. Yep. As a companion app of my car dot companion type. So let me just do a little bit of double back here. So what I'm saying is, when I created a new instance of the car, you see this looks like just the previous ones I've been showing us up until this point where I call the companion app. So what happens is, if I say my car dot make, so if I actually do this make, you see, if I let me see if I can actually do a zoom in, you can see it's calling from automobile right here. But if I go to companion app, let me mouse over it, it's calling from the car class. So you can see the difference just there. So that is simply how it works. So I'm getting properties from the automobile class and also defining my own. So if I go ahead to run this now, I'm able to see this my T printed out also here. But don't worry about all this stuff I have here, all this C# stuff, right? So if I go ahead and click that, I'm able to excuse me, I'm able to see things happen. So that is running now. So you can see, yeah, our Toyota Prius as a companion app of my T. Whereas that was not the case when we were not doing inheritance. So that's simply the concept of inheritance. I wish I could go more in depth, but time will not permit me. And of course, we are not going way in depth. I think I have a repository of some C# fundamentals you can grab on GitHub. If time permits, I'll show us before I round up. So let's now go to the concept of polymorphism. Just from the definition of it, from the word itself, poly means many, morph means shape or form. So polymorphism is simply the ability of an object or a class to exist in more than one structure or form, whatever you want to call it. So it provides the functionality to override methods and attributes of a superclass. So to show that, so if I go to the polymorphism part here, so in my car, I've done a little bit more work here. So what happens? So I mentioned that you should not worry about that virtual I had the other time. So if I go to my automobile class, you see here I have virtual. So what virtual does is it enables me to be able to get my own version of the stop method. So when I get my own version of the stop method, I'm able to work on it by calling it virtual. So So this is what I did here now in class. So I'm able to call my own version of the stop method here. So if I go to my program and run it, I will see that okay, let me just run it. So polymorphism, I go and run. So I go run this now. If you look, so before it runs, I'm waiting for all that stuff to get started. So if you look at the stop method, the stop behavior in this stop, it's just supposed to print out car engine is stopping, right? But if you look in the console, we are seeing that, oh, not that. We are seeing that it's telling us that Toyota Prius 2015 is stopping. Why is that happening? It's because of polymorphism. I have been able to override that behavior in my own subclass. So this is where I did the overriding. So remember, this was virtual here. It means I can override it, and then when I got to my own implementation of it, I override it with this keyword. Of course, in some other programming languages, it will not be this keyword you would use. So that's where that is coming from. We get? Let me see if I can actually. Huh? Nice. I could actually do this, but let me not confuse us and bring it back. Right. So that is that about polymorphism, and actually that's it for this week. But before we go, what we're teaching next week. So next week we're talking about building web applications. Uh, yeah, it should be fun, and hopefully under 30 minutes, just like this episode. I think we're running about 25 minutes or so now, which is awesome. But as a reminder to get alerts when I'm going live and stuff, do well to follow my website. This is where so I post a recap of every stream that happens on every episode, and also I tweet a lot on Twitter. And good news, I just released a new app this week, so you might just go and check it out. Yeah, that about that. I won't say more than that. And of course, follow me on Twitch, Mixer, YouTube, Periscope, or Facebook, whichever one you like. Okay, so you're not bound to just one platform. You can watch on any platform you decide to watch this from. Yeah. So once again, I want to say thank you very much for joining today. Next week should be fun. Yep, it should be. I know it should be for me. So thanks once again for joining. Have a very, 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 very nice week. Stay blessed, y'all.